So, I'm going to talk about. Welcome. I'm going to talk about our cloud migration that we did with our continuous delivery process. I'm getting some mic. Hello. And let's see. Yes, and I'm Tomas Riha, and I work at Volvo Group Telematics. We sell telematics services under the brand WirelessCar, and which is basically Internet of Things for vehicles. I don't like roles, I don't like titles, but I'm usually referred to as an architect. About 8-9 years ago, I realized that I'm probably the worst thing that can happen to a project. I'm really bad at doing manual, repetitive stuff, manual testing, getting stuff into environments, manually following instructions. I'm really bad at that. So I kind of started mitigating the risk of myself by automating stuff around me, and started with automating test automation, and it's gone towards continuous delivery ever since then. 4 years ago, something like that, we started building a new delivery platform. We had been delivering basically siloed deliveries for all our customers, and we kind of got tired of that and wanted to move towards a more microservice-based delivery where all the customers share the same services. We realized that in order to succeed with this, we really do need to do something about our regression testing. Otherwise, we would just break stuff for each other, so we started doing continuous delivery. At that time, we just called it continuous regression testing, since it was about the time the term was born. We had a few problems back then. We still have a lot of them left. We had a low level of virtualization in our production environments and in our test environments. Usually it was you get 2 instances and a database per delivery, and that's what you get. If you're happy, you get 2 test servers, one for early testing, one for QA testing. We had still have split operations and development departments. And infrastructure architecture has been separated from application architecture for quite a long period. And the process of ordering infrastructure has been really long. And all these things don't work really well with microservices and continuous delivery. But we kind of rolled with whatever we had and tried to do the best of the situation. We want to build the new platform, something like this, with microservices that are self-contained, with self-contained databases and life cycles and everything. It didn't happen. Ended up being something like this because we got the 2 big servers and the big database. So eventually it became some kind of monolithic thing that still split into parts, ending up in 2 servers with some kind of load balancing in front. We did do a lot of continuous delivery work on this. We basically had separate build pipes for all the broken apart things that could become microservices. We then kind of took what we had and packaged it together and did integration testing on that, on the full pipe. So basically everything that was in these boxes here was tested like this with component tests and then integration tests on every code commit. When we started doing this, we had the 1 test server that we got and the build server. Quite quickly, when our team became more than just 3 code committers, we realized that the 1 test server is kind of a bottleneck because every pipe kind of stacked up waiting for that test server to become free. We started solving that by doing something like this. We created basically a pool of workers, Jenkins slates in this case with the master, and basically put everything in a big pool. Kind of worked. At least we got some kind of multi-threadness into it. We started moving stuff into a good mastermind. Is our repository of metadata around the builds. Eventually we started building a GUI that kind of visualizes the entire process, but still kind of static. Problem thing with this was that capacity planning was a pain. We're adding a new delivery, we're adding a new team. How many more workers do we need to be able to accommodate for that? We basically, developers tend to check in code just before lunch and just before they go home. Especially before they go home, they want the feedback really quickly, or otherwise they go home anyways. And last one to leave is the one to deal with all the red bills. That person usually tends to get kind of tense in the cheeks, and if you're lucky enough to have a person like that. But so it's kind of hard to deal with the peaks and understand them, and to know how to plan for capacity with more teams onboarding. We spent a lot of time pampering the snowflakes. Each server, we added servers basically as we capacity planned, and we got them from our operations department. They had applied the baseline on it. The baseline didn't have any sense of versioning. It was just current state of a script. So all of them looked different from the beginning. Then we kind of made them look more similar, rolled out stuff on them, had to maintain a life cycle for each of the nodes, cleaning them up. Messy, took a lot of time. But still, we did something right, because our management really liked the fact that we're doing continuous delivery, and one day I got the question, well, this continuous delivery thing, can we deliver it to the entire company? I was like, sure we can. And then I started to think, what does it really take for us to deliver to the entire company, to go up to 400 developers? We were at maybe 70 at that time. And I really realized that there's only one way to go, and that is to use cloud infrastructure. There's no way I'm going to deal with road mapping all the different legacy systems and capacity plan for when to add servers and maintain all the manual servers. So we really had to do something about it. We said that to do this, we really need some kind of cloud infrastructure like Amazon. We had been working a little bit with Amazon before, because we had some load testing issues where we really needed to kind of get towards separating the components, as we had said, in the microservice way, and not have everything in one just big JBoss, so we could understand what it is that was creating load issues for us. So we had kind of started playing around with Amazon. We had a pretty good vision of where we want to go with the cloud environment, so kind of used that to sell the fact that we wanted to go to the cloud. And we actually got to go ahead to move our entire continuous delivery implementation into AVS, and also our demo environments. That's another pain point we've been having, is that we do quick sales demos for during RFQs for our customers, where we need to have something up and running in 2 weeks, and having static infrastructure delivered in 9 weeks is kind of a problem. So demo environments and continuous delivery, we got last spring go ahead to move into Amazon. We really had to make sure that we still were able to deliver into Volvo environments, into our hosting partners in red countries, China. So we need to keep our environments compatible, deployed in ways that is feasible in all the environments and not depend too heavily on Amazon PaaS services for things like queues. For example, we need to use the same queue systems in the different environments. So we need to keep it similar, and otherwise it will go ahead. We had all the servers that we had that were kind of semi-automated maintenance on them. We were using Chef to provision them. We had our Jenkins jobs were generated, so it was no manual work doing the Jenkins jobs. And we had obtained some experience working with building Amazon machine images from the load test work that we had done. And through the load test also, we had a basic understanding of how our different components would behave in a cloud environment and what the potential pain points could be there. So what we needed to do was we needed to build a virtual private cloud connected with the Volvo network. And then we had to migrate about 800 Jenkins jobs from about 60 Jenkins slaves and masters, one huge Nexus server, few test databases, Sonar, Elasticsearch, Logstash, and Kibana, and our custom repository, our custom GUI, and the MongoDB database that was a custom GUI. So this was what we set out to do. Our approach was that we really wanted to change as little as possible from the way we set up the build environments and from the way we did the tests. So basically move it first and then start using the cloud capability once we have moved, because usually when you migrate and transform things, it's kind of hard to get finished. But we said we're going to automate everything and in the right way. So the changes that we do have to come from increasing the automation around how we manage the infrastructure. And then we had to also establish clear responsibilities between our operations department and the development department, who is responsible for what. And that was actually the first thing that we did, and this was how that split of responsibilities panned out. The network team, which is part of operations, is responsible for the Volvo network and the connection to the Volvo network, and inside the Orange Cloud, the VPN router that is in there. We're using a Cisco virtual V1000 or whatever it's called router. We provision that virtual image, make a machine out of it. We create the networks, but they are responsible for the configuration in it. So they own the connection between Amazon and Volvo, and we own everything that's in the cloud. The stuff that we build in the cloud, we had a vision already from when we started doing the load testing, and it's going to be growing, how we want to view our environments, everything that we build there. We want to separate the view of the topology and the environment scale into two different entities. So basically, the topology of a application could look something like this. There's a load balancer, there's server instances that are part of a outscaling group in the Amazon case, and then there's some sort of data store, be it Oracle or Postgres in Amazon's RDS service, or be it a custom hosted MongoDB. And also in the stack of the topology, we include the security groups on each level. So the load balancer, the defined firewall rules for that one, for the middleware cluster there, and for the data store, that's defined in the topology, because regardless of which environment you go into, the security should look the same. And then when we apply the second part, that's into what subnet, in what VPC do we launch this stack, and at what scale. That basically comes from the other environment-specific part. So we can, if we launch a test environment, then we launch it into a specific subnet or specific VPC, and we launch it in a big scale, maybe a little bit higher instances and more of them. If it's for functional testing, smaller instances, less of them. And what we did was that we created two specification files for the topology and the environment, and we created an interface with an implementation that is working on the cloud providers' APIs. Our vision is that we want to have something like this, that we do our local desktop development environments in a lot of vagrant areas, probably going to be more towards Docker someday, and then a cloud provider implementation, and then, I mean, for our legacy, at least we can use this to generate a specification of how we want it to look, so we can send it to a hosting partner to build this, or to our operations. But we started in building this just for Amazon specific, to build all the environments that we had. So we defined the topology spec and the environment spec, which is basically YML configurations that simplify and make a little bit cleaner configuration files of Amazon's CloudFormation YML, and we transform to that, and then we use the CloudFormation API to create the environments. Then into those environments onto the server instances, we launch machine images. We built them in a layered approach, pretty much as you would do with Docker, because we're kind of preparing to moving towards Docker eventually. So we start with a Red Hat image, then we have a Git repository which has all the scripts needed to bring it up to a base level, and using Packer we bake the base image, and then the next level of image, if it's a Jenkins server or if it's a Java server or whatever, we do that depending on that base AMI that was built by the previous repository, and we use our continuous delivery pipes to build these images as well. So we basically use our own tooling to build the images. The nice thing about this is that you're able to share functionality, but you're not sharing code that builds your infrastructure. When we started, I think here's just the hierarchy that we actually had. It's the AMI, and then it's the base level, and then it's our the things that we actually spool up. What I was going to mention, when we started, we had chef scripts that we were running on the Snowflake instances we had, and those basically took from more or less clean all the way up to a fully provisioned Jenkins. So they were doing quite a lot, and they were designed to run on these Snowflake instances that were in an unknown state. And when we started using those same chef cookbooks for building machine images, where you go from a known state to a small delta and in a repetitive, reproducible way, it just became a mess. That's when we started splitting things up, so that we don't share anything between the repositories. So one repository builds one image, and it has all the infrastructure code self-contained, and we depend on the image, the base image instead, which is a much nicer way of sharing stuff with dependencies instead of code sharing. So we got to the migration. What we did, we had the first phase, which was the political phase. we had to get the improvement and establishing the responsibilities between the organizations, getting operations to deliver to us, and all handovers. It always takes time. That was more than, I think, 2-3 calendar months or something like that in the first phase. We did some mocking on during this time on the provisioning, how we wanted to work with cloud formation, so it wasn't a wasted time. Then during the second phase, we were actually building all the automation, building up the VPC, tearing it down, building it up, starting to get the Jenkinses up, viewing them, but actually not moving anything into it. I think we must have torn it down at least 100 times. But it was pretty quick work, 1.5 months for 2 engineers to build all the automation we needed to start migrating. And then we started to move things over. We did another quite important change, and it was to how we actually generate the Jenkins build pipes. We had before like each team got their own job which they configured to generate the pipes for their own repositories. Instead we moved that, so we put a .delivery engine YML into the root of the repository, pretty much the way you see with cloud-based continuous delivery services like Travis or something like that. So that type of file into the root of the repository, and we're monitoring all the Git repositories that we have in the building and basically generating up pipelines for everything that had that .yml file on it. And it was kind of, that made the migration much simpler for us, because we just put the file into each of the repositories and it kind of popped up in the new environment, so it was pretty nice. And then once it popped up, we disabled it in the old environment, and we kind of went repository by repository doing that. Took about a month for 3 engineers, because we had, I mean, as I said, we had like 800 Jenkins jobs, so it was like probably, I don't know, somewhere around 100 Git repositories, maybe, something like that, 80, maybe, something like that. One thing that was kind of nice to have during this migration period was the ability to measure cost. AVS has a great cost tracker where you have graphs like this. This is a granularity by day, so you kind of see the cost for each day. And unfortunately, I didn't have an image that was older, because then you would have seen how we kind of increased our usage. And that's kind of nice to, when you move stuff over your build, to see the cost from the previous day, that you see that you didn't fuck anything up, because I mean, it's easy to in some way generate too many instances, forget to turn off big databases or stuff like that, and you see that right away and can address that. And also here you see that we kind of scale a little bit, so we go down in cost on weekdays. Bosses love this, when you're actually able to show them what your continuous delivery infrastructure costs on a by-day basis. We can also, we tag everything that we build in Amazon, we tag it with a delivery engine tag, and that we are owning it, but we also, when we do stuff, there's specific for specific teams, because they have specific needs, because they're not fully adapted to the way we propose them. We tag it with a tenant tag as well, with their team name, so that we see that they drive extra cost for us. It's quite powerful. One big lesson learned was that when we did all this prepare, automate, verify, once you're ready to go, you should just rip the Band-Aid and get it done. We tried to do it in a kind of seamless way, where we would move pieces at a time, which resulted in us having like our Nexus in our on-premise data center, and the build servers in Amazon. The bandwidth was a little bit too little for that. And so it was kind of a little bit of a bumpy ride, and it was just because we tried to be seamless and tried to mitigate the pain for everybody instead of just saying, okay, on Mondays, since you have your Scrum plannings anyways, take Tuesday and Wednesday for it as well. Give us the 3 days and the weekend, and we'll just migrate everything. That would have been much better. And eventually, the last bit of our migration, we did like this, because our on-premise infrastructure started falling apart. We started to get disk errors and read things. So we actually got really lucky that we were migrating at the time when we were. Otherwise, we would have lost our entire continuous delivery infrastructure. So we actually ripped the Band-Aid, did the last migration in 3 days, and we're done with it. So a few things that we did well was the automation. We did it to such a level that we have not, since we started migrating, we've not launched a single instance manually through the ABS console. Everything is launched through the continuous delivery process itself, which is quite nice. And we have some things that we actually do launch, but those we do launch through our tooling using REST calls. So it's still everything is done through the tooling. And only thing we use the console for is to kill nodes. Sometimes we still have nodes that turn out bad because we still have a little bit of reuse. I'll get to that. So we just terminate and new nodes pop up since we have everything in auto-scaling groups. So we have more or less the same setup as we did before. That was one of the goals because we wanted to migrate in the same way. We did a little bit of sharding in a different way so that some components would get their build jobs on the yellow stack and others on the blue stack, and we have like 6 stacks like that. It's kind of nice that we're moving all the metadata into the mastermind and have the GUI visualizing it, because then having to look at the specific Jenkinses is much less needed. We built auto-scaling on our slaves right away because we just didn't want to care about capacity planning. Since we built auto-scaling and we kind of go during night, we have like 1 or 2 slaves up, and then we scale up to 15 and we go back down. That means that we actually cycle through our Jenkins slaves on a bi-daily basis. That means that we really don't need to do much cleanup work anymore on the slaves, which is kind of nice. We haven't done any capacity planning since we moved, which I feel kind of happy about because it removes pointless meetings for me. But there is one still thing that we were not happy about after the move, and that is that this solution is still stateful. If we need to do maintenance on the yellow stack there, then all the jobs that are on the yellow stack are disabled. And we kind of have, our usage is picking up. We have like 250 Git repositories, 150 developers using us. We actually grew during the migration, which we didn't plan for, but organization doesn't really take into account the fact that we wanted to migrate and have things stable. So we grew with about 50 repositories during the migration, and then we have actually added like 100 repositories since New Year. So we've kind of grown a lot. We're expecting to be at least 200 developers using the delivery engine by the end of the year. So we really need to do something about the stability and the availability of the service we deliver, because more and more people are depending on us. And we want to deliver it as a small team. We don't want to grow our team just because we grow the number of teams that consume our service. And if we don't do anything about stability and scalability, then we get support errands that still drown us. So we had to do something about it. And if you read my kind of presentation of my talk, I was going to talk about our roadmap, things we are going to do. This is the part, we've actually done it. It's getting released fully during next week. We have beta teams using the new setup. And we did quite a big restructuring, and it started with the way we look at our jobs. One of the problems, there's tons of problems with Jenkins for continuous delivery. As I said, with the fact that it's by default kind of stateful, that you set up the pipe for a application on a server, that data is navigated through that setup of that pipe the way it looks at that moment. It's kind of a problem that makes change hard. And also, you want to get the data out of it. And it's kind of hard to test Jenkins jobs. And testing chains of Jenkins jobs is even harder. So we decided to kind of finally start moving away from Jenkins. And first step towards that is to actually build a framework for build pipes ourselves. There's call it build pipe as code. It's a code framework which in a pluggable way allows us to define build pipes. There's a client for that framework, and that client is executed by the Jenkins job. This gives us the ability to unit test each task that is in the pipe and to integration test the pipe itself, so we kind of get continuous delivery of the build pipe mechanism and the build pipes. Then the data is moved out of the job into different databases. As I said earlier, we had the mastermind database for the metadata, but we kind of added more different types of stores for different types of data. Then we decoupled the Jenkins job from the Git repository by actually having the Jenkins job listening to a RabbitMQ and having a Garrett listener which listens on all the events on our Garrett and puts them on the RabbitMQ. And the Jenkins job, and I'm saying the Jenkins job because we now have just one Jenkins job which listens to that queue and picks up the repository, and from that YML configuration file in the repository knows what type of pipe to use for that repository and selects it from the pipe as code. Then we took the AVS tooling that we had built to provision the delivery engine and integrated it with the build pipes to create test environments on the fly. So every time a pipe starts, it creates a clean, fresh test environment in parallel with building the code itself. So we don't wait for the provisioning, it happens in parallel. So if we look at it from a little bit higher perspective, we added Elasticsearch so that all the logging from the pipe framework goes into Logstash. We moved test reports onto S3, basically run site plugin and move the entire site to S3. We run matrices into Graphite and still have our metadata repository in Mastermind. And we push events to Slack to provide feedback, let users basically decide what level of push notification they want. And we have our custom GUI. The thing is, I was showing the execution of the build pipes as code happens in what we call the factory, which is basically a stateless setup of Jenkins, which is the Jenkins job and a worker. And that Jenkins job listens to the RabbitMQ, which means that if we need to scale up and add another factory, we just add another factory it listens to the same queue, it picks up and starts building it, and when we need to decommission a factory, we just turn off the queue listener, let the jobs finish off, and then we just tear it down. So we basically cycling new updated factories while it's up running, and we can do high availability updates. And as I said, this rewrite, when I first kind of sent in this presentation, I thought that would take the entire spring for us to do, because that's the pace we've been rolling stuff out. But with Amazon, things so easy to do. We basically set up things in parallel. We don't need to capacity plan. We get the servers when we need them, and we've freed up so much time from all the cleanup and capacity planning and stuff like that. So we actually just produce much more value as a team by not maintaining all the servers. So it took about a man-month to create a framework for the pipe as code, to integrate it with the ABS tooling, with our data stores, move things to S3, and listen to the RabbitMQ queue, and all that took about 1 man-month to do. So if we look a little bit on a kind of retrospective way of our migration, lead time for getting infrastructure gone, ability to build HA and scalable applications is, well, we couldn't have done this with our old infrastructure. Have I said before, no more capacity planning, super nice. Demo environment, I talked about it earlier and said that we also got to go ahead to build